All right, welcome to The Explainer. Today we are digging deep, and I mean literally, into one of the most incredible ideas in ecology, the theory that forests are all connected by this huge underground communication network. Okay, let's get into it.
I mean, it sounds like something straight out of a movie, doesn't it? This idea that trees can actually share resources, warn each other about danger, and even take care of their own kids. But this whole concept isn't just fantasy. It's actually rooted in some really fascinating and, yeah, pretty heavily debated science.
So the popular name for this whole thing is the Wood Wide Web, like a natural internet that connects an entire forest. This image gives you a sense of just how complex that hidden world might be. But to really get the story and the controversy, we've got to understand the science it's all built on.
So what is actually happening down there, right beneath our feet? Well, it all boils down to this amazing partnership between trees and fungi, and together they form what scientists call a mycorrhizal network.
Okay, so a mycorrhizal network is a real thing. This isn't science fiction. It's a symbiotic alliance. You have these superfine fungal threads, they're called hyphae, and they weave themselves into and all around tree roots, physically connecting different plants. This isn't just two things living next to each other, they are literally plugged in together.
The whole relationship is based on a trade. You can think of it like an underground economy. The trees, they've got the sun, right? So they make sugar through photosynthesis, and they send that sugar down to the fungi as a form of payment. And in return, the fungi act like master miners, breaking down soil to get all these vital nutrients and water that the tree roots just can't get to on their own. It's a total win-win situation.
Now, the scientist whose name is most connected with this whole idea is Suzanne Simard. Her groundbreaking work back in the 90s actually used tracers to show that, yes, carbon could move between totally different species of trees through these fungal links. Her work painted this incredible picture of a cooperative, talking forest.
And what this image shows is that these networks aren't just a random jumble. Just like our own brains or social media, they seem to have what's called a scale-free structure. That means they have hubs, older, bigger, more established trees that are super connected. Simard calls them mother trees, and they act like these central points, linking out to tons of smaller, younger trees all around them.
But, and this is a big but, as this incredible story of talking, nurturing mother trees just exploded in popular culture, a group of scientists started to step back and ask a tough question. Has the story gotten way ahead of the actual science?
So the heart of the issue wasn't that the basic science was wrong. It was that the story had become so much bigger than the evidence. This narrative of a totally connected, almost conscious forest was spreading like wildfire. But the hard data from actual field studies, well, that was a lot more limited and way more nuanced.
Ecologist Justine Karst is one of the key voices calling for a bit of caution here. She and her colleagues actually published a paper that went back and re-examined all the evidence for the biggest claims about the Wood Wide Web, basically comparing the story we all love to tell with what's actually been proven out in the field.
And this table right here, this really gets to the core of the debate. Let's just walk through it. First, the claim that these huge networks are in every forest. The reality? We've only mapped them in a tiny fraction of forests. We just don't have the data to say it's universal. Second, the idea that big trees help little seedlings survive by sending them food. Well, the evidence here is all over the place. Some studies show it helps, some show it actually hurts, and a lot show it does nothing at all. And third, that big one, trees sending warning signals about bugs. This is one of the coolest ideas, right? But according to this big review, it's not supported by a single peer-reviewed field study. The evidence we have comes from lab experiments which, as you can imagine, don't always translate to a real, messy, complex forest.
So where does all this leave us? Is the Wood Wide Web just a myth? Well, not exactly. The truth, like it so often is in science, is a lot more complicated, and honestly, it's way more interesting.
Here's the critical point. This isn't about debunking the whole idea. The debate is about exaggeration. Yes, mycorrhizal networks are real. Yes, stuff gets transferred through them. But the story often makes this huge leap from transfer is possible to trees are intentionally communicating. And the hard evidence for that level of complexity and intent, it just isn't there yet.
And this overstatement has a real impact. Karst and her team found that the number of scientific papers citing these big claims without really strong evidence has almost doubled in the last 25 years. That's how a popular story can actually start to warp the scientific conversation itself.
So let's just bust two of the biggest myths right now. First, this idea of conscious trees with intentions.
What scientists are actually seeing are biochemical processes. A stressed tree might leak some chemicals that a neighbor picks up. It's more like passive eavesdropping than sending a deliberate text message. And second, the idea of one giant forest-wide web. The reality is probably more like a bunch of separate local networks. Think of it less like one global internet server and more like a bunch of disconnected local group chats.
Now, with all this debate, it's easy to think that scientists just don't agree on anything. But that could not be further from the truth. There are some fundamental things about these fungi that are totally, 100% undisputed.
And despite all the back and forth, there's a powerful consensus here. Everybody agrees that these fungi are absolutely the lifeblood of a healthy forest. They are essential for getting nutrients, they protect roots from disease, and they play this massive role in locking carbon into the soil, which is, unbelievably important for fighting climate change.
And this is the real takeaway. The scientific process isn't about proving a cool story right or wrong. It's about refining our understanding. No one, and I mean no one, doubts how important these fungi are. The real work, the ongoing debate, is all about figuring out the exact rules of how these complex underground networks actually operate.
And that brings us to the final and maybe most important question. Why does all this nuance matter? Why not just enjoy the cool story? Because good science is absolutely critical for making good decisions about how we manage and protect our forests. By understanding what we actually know versus what we just hope is true, we can make much smarter and much more effective choices for the future of our planet.